Today in pre-cal we started learning about the sum and difference formula. This is kind of a standalone lesson. It's the last set of formulas we're going to cover on your Coral paper. And I'm just going to show you a couple of examples of how to do this. You're basically just using those formulas though. You're only looking at the ones for sine and cosine and the sum and difference formulas for those. Let me point those out to you on the bottom here. The rule for a sine, if it starts out with a sign of u plus or minus v, so u plus v or u minus v, it's one or the other, then you're going to follow this. You're going to take the sine of u times the cosine of v plus the cosine of u times the sine of v. If it starts out as the sine of u minus v, it'd be the sine of u cosine of v minus the cosine of u sine of v. Notice the plus or minus here and here match. On cosine, if it starts out as a cosine function, you're going to do u plus or minus v, so u plus v equals cosine u cosine v, and then minus comes first on this one, sine u sine v. If you were doing cosine u minus v, it'd be cosine u cosine v plus sine u sine v. Okay, let's look at some examples. Number 1. If I have the cosine of 75 degrees, that would be broken down into the cosine of 45 degrees plus 30 degrees. Okay? And I would be giving you that part right there. We know that 45 plus 30 is 75, and the important thing there is that 45 plus 30, 45 is on the unit circle, 30 degrees is also on the unit circle. So I'm going to follow the cosine formula. My u is 45 degrees, my v is 30 degrees. Okay, so I'm going to do the cosine of 45 times the cosine of 30, and then for cosine the sign in the middle flips, so this is positive, now I'm using negative, times the sine of 45 times the sine of 30. Now if I use my unit circle I can begin to solve that. The cosine of 45 is root 2 over 2, that's again from my unit circle, cosine's the x value. The x value at 30 degrees is square root of 3 over 2 minus sine of 45, root 2 over 2. And the sine of 30 is 1/2. Remember, sine is your y values. And then we're going to multiply straight across. Square root of 2 times the square root of 3 is the square root of 6. 2 times 2 is 4. Minus, square root of 2 times 1 is the square root of 2. And 2 times 2 is 4. And I can combine that into one fraction as the square root of 6 minus the square root of 2 all over 4. There isn't anything I can do to combine these two because I cannot simplify the square root of 6. Let's look at an example of sine. So sine of pi over 12. Sine of pi over 12 can be broken down into the sine of pi over 3 minus pi over 4. Again, I would be giving you this part right here, and that's as a result of common denominators. If I made them 12, it'd end up being 4 pi over 12 minus 3 pi over 12. That's pi over 12. Using sine, the formula tells me my u is pi over 3, my v is pi over 4, and so I'm going to do the sine, I'm just plugging it in, sine of u, sine of pi over 3, times the cosine of v, pi over 4. Sine stays the same, so it's minus the cosine of pi over 3 times the sine of pi over 4. Okay, when I do that, the sine of pi over 3 is square root of 3 over 2. The cosine of pi over 4 is square root of 2 over 2, minus the cosine of pi over 3, which is 1/2, times the sine of pi over 4, which is square root of 2 over 2. If I complete that out, I've got square root of 3 times square root of 2, which is square root of 6, over 4. 2 times 2 is 4. Same thing here, so I'm going to go ahead and combine these. Minus 1 times the square root of 2 is the square root of 2. My answer is the same there, and that'll happen pretty often, guys, because there's only so many values on the unit circle. When I multiply them out, they're often going to yield the same answer. Example 3, going the other way. So if I was given something like this, sine of 42 cosine of 12 minus cosine of 42 sine of 12. Okay, the reason I say this is going the other way is this is starting out with several different pieces instead of just one. This would be the second side of the equation, and it has sine and cosine together in the first piece, which clues me into the fact that I'm using sine here and not cosine, because the cosine one starts out cosine, cosine. So I'm doing sine of 42, that's my u, and 12 is my v. For sine, the middle sign stays the same, so that's subtraction. 42 minus 12 is 30. And then that's something that's on our unit circle. So the sign at 30 is 1/2. And that's our final answer. I'm going to do one example from your homework with you because this right here was on the unit circle. We could keep going. On the next one, we won't be able to. This is number 24 on your homework. If I have the sine of 140 times the cosine of 50 plus the cosine of 140 times the sine of 50. Okay, again, I have sine cosine, which clues me in that I'm using sine. I've got 140 and 50 as my u and v. There's a plus sign in between here, so there's a plus sign in between here. My answer is the sine of 190. That is my final answer. Since 190 isn't on my unit circle, I can't keep going. The assignment for today is assignment number 8, page 404, numbers 1 to 4 and 23 to 24. One more thing I want to show you, example 1, and let's just call this part B. This is from example 1 in your notes earlier. You'll see that I gave you the cosine of 45 plus 30. It will give you a part B in your homework 1 through 4 where it'll say, okay, now find me the cosine of 45 degrees plus the cosine of 30 degrees. Instead of the cosine of 45 plus 30. The difference is this is two separate cosines. Cosine of 45 is root 2 over 2. I'm not using those formulas that we learned today. This is just old stuff, just plugging in my answers. Cosine of 30 is, sorry about that. Let's see, cosine of 30 would be square root of 3 over 2. And then I can combine those because they have a common denominator of 2. So it's just the square root of 2 plus the square root of 3. And that would be my final answer. Notice that is not the same as what we got on example 1 because if I write it this way with two cosines, that's totally different than what I did in example 1 where I said 45 plus 30 inside of parentheses. Hope that helps. If you have questions, see me in tutorials.